Hello. So the first question is that in photoelectric effect, the work function of the metal is 3.5 electron volt. The emitted electron can be stopped by applying a potential of 1.2 volt. Then, so first let me write the question. The question has given the work function of the metal as 3.5 electron volt and the stopping potential as minus 1.2 volt. Okay. So these two things are given in the question. So if I apply the photoelectric equation by Einstein, it says that energy of photon should be equal to phi plus kinetic energy possessed by that electron. Okay. So if the energy loss is zero, the collision of the electron, if we will neglect it, then the kinetic energy will be maximum because energy loss is zero. Okay, and what is work function? You might already be knowing that electron need a certain, or you can say the minimum energy to come out from the surface of the metal. For example, assume that the photon is coming and striking on the metal surface. An electron is there. The photon will strike on the electron and electron will gain the energy from photon, and then this electron will come out. Electron will come out because it might be having, or the photon might have supplied the minimum energy that is equal to work function. If the electron has equivalent energy to the work function, then definitely electron will come out. And the remaining energy, if the photon is having more energy than the work function, then definitely some energy will be utilized as work function. That means in crossing the barrier, and rest energy will be possessed by electron as its kinetic energy. But we are assuming here that the energy loss is zero. That means there is no energy loss. Either the energy is utilized in work function or as in kinetic energy. Okay. So we are given here as stopping potential. Stopping potential, what does it mean? It means our electron has come out from the metal surface. It is possessing some kinetic energy. An electron is moving. So we have to stop that electron. That means we have to apply opposite potential or the equivalent energy to the kinetic energy of the electron to stop that electron. Okay. So the negative potential, negative here shows the direction. Negative here just shows the direction. That means direction of that potential will be opposite. So the kinetic energy should be equal to zero. Kinetic energy is made to be zero. That means electron was traveling or electron was moving. We should stop that. That is called as stopping potential. Okay, and you already know that work done, or you can say the energy, we have to change this volt into electron volt. That means energy, stopping energy. That will be equivalent to kinetic energy. So what we can do is we can multiply this volt by charge, and that charge will be charge of electron. So I can write it as 1.2 electron volt. This should be the minimum energy required. Okay. So according to this equation, if I have to calculate, if I suppose to calculate, or if we will calculate the energy of photon, then that should be phi plus this kinetic energy, and then kinetic energy should be 1.2 electron volt plus phi. Phi is work function and it is given as 3.5 electron volt, and that sum total is 4.2 electron volt. That means the energy of the photon should be minimum 4.2 electron volt. That means at least the photon should possess 4.2 electron volt. Then only the electron will be emitted and the electron will possess minimum energy of 1.2 electron volt. So now we are coming on to our option. The first option says that the energy of incident photon is 4.7 electron volt. Energy of incident photon is 4.7 electron volt. Definitely this is the right option as we have already calculated. So this 3.5 or this will be 4.7. Okay. So the first option is saying the energy of photon must be 4.7 electron volt. So it's a correct option. We have already calculated that minimum energy possessed by photon should be 4.7 electron volt. It can be more than that also. That will not make any difference. Emission will be there. So if the energy will be more than 4.7, then the kinetic energy of the electron will be more, or the stopping potential will be more. Okay. Now the second option is the energy of incident photon is 2.3 electron volt. Energy of incident photon is 2.3 electron volt. See, you can already make it out that the energy of photon is so less, it can't be able to you can say the emit electron, because it is less than work function. So if the energy if the photon with this energy will fall on the surface, then the electron emission will not take place, as the energy is even lesser than work function. So there will be no emission, and rest you can think about the stopping potential, because electron is not emitted, there is no existence of electron, so to whom will you stop, isn't it? So it's also a wrong answer. Third option. The third option is saying that if higher frequency photon be used, the photoelectric current will rise. They are saying that the higher frequency photon means if the frequency will rise, then energy will rise. They are saying if the photon energy is increased, then the current should increase. This is also a wrong option, because you have studied that the value of the current depend on intensity of that photon beam which is striking the metal surface. It is independent of the energy of the photon. Okay, so it doesn't depend on energy of the photon, it depends on intensity, that means number of photons striking per unit time per unit area on that surface. Okay, so if you will increase the energy, then current will not increase. In turn, the kinetic energy of the electron can be increased. That means if we are attaining certain value of saturation current in some time, so we can attain it fastly we can attain that saturation current value by increasing the energy, but the value of saturation current will not change. Okay, so now the fourth option is, so third option is incorrect. So we are coming to the fourth option. Fourth option is saying when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. It is saying that if the energy of photon is equal to 3.5 electron volt, then current will be maximum. See, you can also we have already discussed about it. You can see that the energy of photon is 3.5 electron volt. That is just sufficient, or that is just equal to work function. That means in this case, definitely the emission of the electron will take place, because the photon is possessing energy equivalent to equivalent to your work function. But the kinetic energy, if whole energy is consumed by phi, then kinetic energy will be 0. So electron will not move at all, and if electron is not moving, then the value of current will be 0. It cannot be maximum. So the fourth option is also incorrect. So what our answer is? Our answer will be first option. So now let's move on to the second question. Second question, it is given that the stopping potential versus frequency plot. So this is stopping potential and this is frequency. This is frequency, and here the unit is V into 10 to the power 14 Hertz. That means if the value is 5, so 5 into 10 to the power 14 Hertz. So this is the graph given, and we have to tell about the threshold wavelength. So what is threshold wavelength? What is lambda naught? Threshold wavelength, if I'll say. Lambda naught is the minimum wavelength. Lambda naught is the minimum wavelength which is required to emit electron, or to cause the emission, or to cause the photoelectric effect. That means we should possess the minimum lambda naught or minimum wavelength to cause the photoelectric effect, or to emit the electron from the metal surface. That is called as threshold wavelength. So we are having in this graph, according to Einstein photoelectric equation, we can write that energy, or you can say the h mu, that will be equal to phi plus kinetic energy of the emitted electron. So threshold means just emission. Okay, kinetic energy should be 0. That means we are just providing energy just equivalent to phi, that means work function of that metal, and that should be our threshold wavelength. So kinetic energy will be 0. So whole energy will be utilized in work function. Okay, so the kinetic energy will be 0. That means above this graph there is some frequency possessed by electron. That means there is some energy possessed by electron. frequency or the energy of electron is 0 at this point where the graph is touching at this frequency. That means at this frequency the photon, or you can say the electron, is possessing minimum energy. At this frequency the electron is possessing minimum energy, so this point will be equivalent to threshold wavelength. So we can write as threshold frequency is 5 into 10 to the power 14 Hertz. Okay, this is the threshold frequency. So mu naught, this threshold frequency, we can write it as C by lambda naught is equal to 5 into 10 to the power 14 Hertz. Okay, so if we have to calculate lambda naught will be 3 into 10 to the power 8 divided by 5 into 10 to the power 14. So it will be, lambda naught will be 6000 into 10 to the power minus 10 we can write, and this will be, you can write it as 6000 angstrom. So the option B, that is saying 6000 angstrom, that is a correct answer. Okay, now let's move on to the third question. The third question is saying that which of the following graph represents the variation of maximum kinetic energy, that means EK, with frequency of the photon. With frequency of the photon used. So according to Einstein photoelectric equation, we know that maximum kinetic energy will be equal to energy of photon minus phi, that means work function. Okay, and the maximum kinetic energy is how much? Maximum kinetic energy versus frequency of the photon, you have to plot the graph. So K max, we can write it as K max is equal to H, that means Planck's constant, into mu, that means frequency, minus phi. Okay, so we can make this equation as equivalent to K max is given on y axis, y is equal to mx plus c. So this is our m, that means slope, this is our x, that is x axis, this is our y axis, and this is our intercept, and this intercept is negative, minus phi. So how our graph can be? Our graph will be like this. Our graph will be like this. We should have a negative intercept on y. That means like this. This negative intercept on y is our phi. Okay, and now here this will go as a straight line. This is our K max, and this is our x axis, that means frequency, and the slope of this line is, slope of the line is m. So this will be the exact graph. So which option is falling into this category? That is fourth option. So the fourth option is correct about this question. Okay, what we have done here is, it's very simple. We have just formed the equation according to photoelectric equation of Einstein, and we have like you can say molded the equation into our given situation, that is graph between K max and frequency of the photon used, in photoelectric effect. So in between these two we have plotted the graph, so the answer will be fourth option. Thank you.